Okay, let's dive right into this explainer. We're looking at the absolute foundation of our modern supply chain. I mean, long gone are the days of plotting early navigation routes with paper maps, compasses, or, staring up at the starry skies. Today, whether you're tracking a single delivery van or a massive global fleet of cargo ships, you're relying on this silent, invisible infrastructure constantly humming above our heads. So consider this your tactical briefing for logistics management. How well do you actually understand the technology keeping your business moving? Well, I want to start by challenging a pretty common misconception you might have. How is your fleet actually being tracked? When you look at that glowing blue dot on your logistics dashboard, it's so easy to imagine your delivery truck actively shooting a laser beam of data up to a satellite, which then beams it back down to you, right? But actually, scratch that. That isn't the case at all. The reality is far more elegant and honestly, a whole lot more mathematically impressive. We're going to structure this explainer into 5 core areas. First, we'll cover the 3 GPS segments. Second, how receivers only listen. Third, trilateration and time delays. Fourth, 2D versus 3D positioning. And finally, number 5, atomic clocks and relativity. All right, let's kick things off with section 1, the 3 GPS segments. Let's see how this entire system is built from the top down. The global positioning system is supported by these 3 distinct pillars working in perfect harmony. You've got the space segment, which is the satellite constellation up in orbit. Then there's the control segment, made up of 24/7 ground tracking stations. And finally, the user segment, which includes the actual hardware, your phones and the receiver chips embedded in your dashboards. Now, the scale of the space segment is just absolutely wild. There are roughly 31 operational satellites currently managed by the U.S. Space Force. While we strictly only need 24 for full global coverage, those extras are up there acting as absolutely crucial backups. They're strategically spaced out so that from any open point on Earth, your fleet's receivers can see at least 4 of them at any given moment. And they aren't exactly close by. These orbiting bodies are sitting at an altitude of over 12,000 miles, or about 20,200 kilometers, above our planet. To put that into perspective for your logistics routes, that's roughly equivalent to driving from New York to Los Angeles and back, 20s. Oh, and they're moving incredibly fast. Each satellite completely circles the Earth 2 times every single day. They are just zooming through the vacuum of space, performing this highly choreographed dance to guarantee that no matter where your cargo is, the sky above it is populated with these digital lighthouses. Meanwhile, down here on the ground, the control segment monitors the system 24/7, constantly correcting satellite locations and clock data to maintain perfect accuracy. If a satellite drifts even slightly due to gravitational anomalies or solar radiation, these ground stations act like a 24/7 IT department. They monitor the paths, they check the clocks, and they send precise corrections back up. This constant correction is what keeps the entire system trustworthy. Okay, moving right along to section 2, receivers only listen. This is absolutely crucial for understanding the user segment inside your driver's cabs. I love this quote because it clears everything up. Your phone has a GPS receiver chip. It doesn't send anything up to space. It only listens. Your logistics assets are completely passive. Think of your vehicle's GPS unit less like a two-way radio and more like a car stereo tuned into a specific station. It doesn't talk back to the DJ. It just listens to the broadcast. And that's a huge advantage, because it means the system can support an infinite number of users without ever crashing. So what exactly are they listening to? Satellites continuously broadcast 2 crucial pieces of data: their exact location in orbit and the exact timestamp from an onboard atomic clock. Every single second of every single day, those 30-plus satellites are just screaming into the void, "Here is exactly where I am in space right now, and here is the exact time I sent this message." Which leads us perfectly into section 3, trilateration and time delays. Let's dig into the math of pinpointing your cargo. So trilateration. It's the mathematical process of determining a precise location by calculating the intersection of spheres based on distance measurements from multiple satellites. It sounds super dense, but it's simply the geometry of finding where different signals intersect. Unlike triangulation, which uses angles, GPS strictly uses distance. And how do we find that distance? Simple equation. Distance equals the speed of light times the time delay. Because radio waves travel at the speed of light, your receiver chip calculates its distance from a satellite by multiplying that speed by how long the signal took to arrive. It's literally the exact same logic you use when you count the seconds between a lightning flash and a thunderclap. But here, the thunder is traveling at a staggering 300 million meters per second. Here are the exact mathematical steps happening in your pocket. Step 1, receive the signal indicating satellite location and send time. Step 2, note the exact time the signal is received. Step 3, calculate. Let's say there's a 0.07-second delay. You multiply that by 300 million meters per second, and boom, the receiver knows it is exactly 21,000 kilometers away from that specific satellite. So let's see how stacking these measurements narrows down a location on a map in Section 4, 2D versus 3D positioning. Step by step, it's like a giant cosmic Venn diagram. Step 1, one satellite gives you a giant sphere of potential locations. Your truck could be anywhere on that sphere. Step 2, two satellites narrow it down to an intersecting circle. Step 3, three satellites pinpoint just two possible locations. And since one of those points is usually deep out in space, your receiver smartly discards it, choosing the one right here on Earth. To break that down, 3 satellites give you a 2D position, your latitude and longitude, but 4 satellites give you a 3D position, adding altitude and exact time. Adding that 4th signal is the difference between knowing your delivery truck is at a specific street corner versus knowing exactly what floor of a multi-level parking garage it's on. But for logistics, that 4th satellite does something even more vital. The 4th satellite corrects internal timing errors caused by cheap receiver clocks, ensuring perfect synchronization with orbital atomic clocks. Look, the clock in a dashboard unit is pretty cheap. If it's off by even a tiny fraction of a millisecond, multiplying by the speed of light means your distance calculation is going to be wildly wrong. The true genius of the system is using that 4th satellite to automatically fix the receiver's internal time error and cancel it out entirely. And that brings us to the final, definitely the most mind-bending part of our briefing. Section 5, Atomic Clocks and Relativity. Time synchronization is absolutely critical here. Orbiting atomic clocks are accurate to roughly 1 nanosecond. Just a single nanosecond of error equals a 30-centimeter distance error on the ground. These clocks measure time by the literal vibrations of atoms. If they were off by just 1 billionth of a second, your routing software would map your driver a full foot away from where they actually are. Now check out this daily error rate table. Uncorrected for relativity gives you roughly a 10-kilometer error per day. Corrected phone GPS is about 3 to 5 meters accurate, and military or dual frequency is less than 30 centimeters accurate. The stakes are huge because satellites move super fast and sit higher up in Earth's gravity. Einstein's theory of relativity states their clocks actually tick differently than ours. Fast movement slows their time down, but weaker gravity speeds it up. It sounds like science fiction, but it is a daily operational reality for your fleet. So by actively calculating relativistic adjustments and atmospheric delays, the GPS system prevents a disastrous 10-kilometer daily measurement drift. Without those constant mathematical corrections sent from the control segment, your supply chain would literally be miles off target by tomorrow morning. Your trucks would look like they were driving through rivers and office buildings. So here is a final thought for you to chew on. If your devices are only passively listening to space, what other signals are they using to calculate their reality? As you manage your assets moving forward, think about these silent, brilliant mathematics happening in your pocket. We've gone from navigating by the stars to carrying a device that listens to atomic clocks flying 12,000 miles above our heads, performing speed-of-light geometry, and correcting for the fabric of space-time itself, all just to tell us to take the next right turn. It is a profound reminder of the unseen infrastructure powering our world. Keep that in mind next time you check your logistics dashboard. Thank you for joining me for this explainer, and keep learning.